This is the Math 2, now Unit 8 final review. We're now on number 47. So QR is the radius of the circle, PQ is tangent to the circle. We need to find QR. What this turns into, because a tangent and a radius are perpendicular, is a Pythagorean theorem problem. So QR is one of our legs, so we'd go 25 squared equals 20 squared plus QR squared. This is 625 equals 400 plus QR squared. It's 625. That's 225 equals QR squared. The square root of 225 turns out to be 15, so our radius is 15. Now for 48, it wants us to find our angle here, and I'm not sure what else because it looked like it got cut off, but we'll find what else we can. So 130 is a central angle. This arc is the same as the central angle, so that will be 130. For the angle, this angle here, WTP, or the angle at T, it is a inscribed, should put 130 there, inscribed angle. So this is going to be half the arc. So we're going to take 130 divided by 2, and that comes out to be 65 degrees. Central angle is the same as the arc, inscribed is half. Now for number 49, we need to find BKG as the angle. A couple ways we could do this. Let's first say this is a central angle, so this will be 84 degrees here. I have a diameter from KG, so if I do 180 minus 84, that gives me 96 down here. Now, just like number 48, this is an inscribed angle, so angle K will be half of 96. So 96 divided by 2 is 48 degrees, and that will be the measure of angle BKG. Another way we could find it. Notice that these are both radiuses, or radii here. So what I could do is, if this was an isosceles triangle and I wanted this angle, which is the one I'm looking for, I can solve this as an isosceles triangle, do 180 minus 84, which is 96, divided by 2 also comes out to be 48. It's another option. They both get you to the same place. The key thing is the measure of BKG is 48 degrees. For number 50, I need to find angle X, or arc X. 156 is not. We don't know if it's the same. What I'm going to do is the inscribed and make that 64. So now 156 plus 64 is 220. If I subtract that from 360, it leaves me with 140 left over for X, which is what's left for the arc. For number 51, I need to find some angles. So first one I could go with, let's say 28. If I double it, it's 56 here, which makes DOL going to be 56 as well. We can also notice that MDL is pointing at a semicircle, which is half the circle. So this would turn out to be a 90-degree angle here. Seeing that it is a right triangle is inscribed here. We could also, what else are we looking for? ODL. If this is 28, 56, we could find this arc. 180 minus 56 gives me 124. Half of that is this angle, which is 62. Now, to find the measure of angle ODL, it's what's left in this triangle, which has 56 and 62. 56 plus 62 from 180 gives me 62 degrees right here. And that also we could see would have been an isosceles triangle, and maybe that's the way we solve it. Oh, I just did that whole problem where you couldn't see it. Let's try it again. All right, this time so we can see it. We're looking for, let's go with ODL first. We said we got 90 degrees here. 28 doubles to 56, and this arc will also be 56. So I know if I take this triangle out, it is isosceles because there's two radiuses there, or radii. In doing that, I solve and get that these two angles are 62 degrees. Now, because this is 62, I'd also know that that would be 124 for the arc on the outside. So that being said, the measure of ODL is 62 degrees. The measure of MDL is 90 degrees. LDM is the exact same. That's also 90 degrees. We could go further and find other parts. We know that's 62. 90 from 62 gives you 28, which would be this angle here. Also another isosceles triangle. So just working through that, you can find the different parts that you need. Okay, some always true, sometimes true, never true. The measure of the central angle is half the measure of the intercepted arc. So I'm going to draw an example of that just to make sure I'm careful with the 1/2 idea. So let's say I have a central angle and it is 60 degrees. That means the intercepted inscribed angle is 30 and the arc is 60. Well, that's saying the arc is half. That is never true. The central angle equals the arc. Circles are congruent. That's sometimes true. They actually need to have the same radius. If they have the same radius, then they are congruent. Now, circles are similar is always true. That's because their corresponding parts or their corresponding sides would be proportional. Think of your radiuses, your diameters. They're going to hold up. It's going to be proportional. Two diameters divide a circle into 4 congruent arcs. Let's look here. 2 diameters, so we have those. Divide a circle into 4 congruent arcs, each with a measure of 90 degrees. Well, they don't have to. If I drew 2 diameters here, they don't have to make 4 congruent arcs. They actually make 2 pairs of congruent arcs. If I made them perpendicular, then they would give us 90 degrees, but that one's going to be a sometimes true.